Good morning, grade 9 students. This is Sir Doms, and today we have a new topic about geological formation of Philippine archipelago. For our intention, competency, participate in a collaborative group or class task to examine and describe the topographical and geological evidence for plate boundaries occurring in the area where the Philippines is located. At the end of the lesson, learners should be able to first explain the step-by-step geological processes that form the Philippine archipelago. Second, sequence and map out the key stages of Philippine Island arc development. And lastly, appreciate how active tectonic forces shape the country's landscape. Think about it. Philippines have 24 active volcanoes. These are volcanoes that have erupted within the last 10,000 years. Philippines is also home to mountain ranges such as Sierra Madre and Cordillera Central. Philippines is also considered an archipelago. The official count of the islands in the Philippines is 7,641. You can also find the third deepest trench in the Philippines, called the Philippine Trench. Think about it. Based on our previous topics, what could have caused the formation of these features in the Philippines? Today, we will dive into the process of geological formation of Philippine archipelago. Are you ready? For our learning experience, we will have an activity titled Philippine Island Formation. And for our materials, we will be needing images of key stages in the geological formation of Philippine formation and worksheets. Your task: first, the students will be grouped into their groupings. Second, they will be given images of key stages in formation of Philippine islands and they will arrange it, then answer the guide questions. So these are the images that the students will arrange. And now for the guide questions for each photo. First is the image of the three plates colliding. Guide questions: Philippine Mobile Belt was surrounded by which plates? Second, what type of plate boundary occurred in this interaction? And now for the picture of the volcanoes forming volcanic island arc. What types of plate converge? The convergence between plates gave rise to which geologic formation? And now for the picture of Palawan. Which island is a part of the mainland Eurasia that broke off and drifted southeastward and collided into the volcanic island arcs? Then, how would you compare the age of this island to the volcanic island arc? Now for the picture of mountains and the Philippine fault. Compression lifts ancient coral reefs and seafloors into high mountain ranges. Like which mountain ranges? Squeezing forces created which fault that relieves the tectonic strain and frequently reshapes the terrain. And now for the picture of the Philippines. The present Philippines is a result of what type of convergence? What are the evidences or geological formations of this event? And now for the presentation, a representative from each group will present their completed output. And now for the answer key or the expected output, the proper arrangement is: first is the convergence of the plates. Second is the formation of the volcanic island arc. And then third is the movement of the Palawan-Mindoro block. And then fourth is the formation of mountain ranges and the formation of Philippine fault zone. And number 5 is the present. And now for the answer key for each questions. Philippine Mobile Belt was surrounded by which plates? So Philippine Mobile Belt is squeezed between Philippine Sea Plate, Eurasian Plate, and Indo-Australian Plate. Next, what type of plate boundary occurred in this interaction? So the answer is convergent boundary occurred in this boundary. And then for the second picture, what type of plates converge? So the answer is oceanic convergence occurred. So it is convergence of two oceanic plates. Next, the convergence between plates gave rise to which geologic formation? So it gave rise to volcanic island arc. And now for the third picture, which island is a part of the mainland Eurasia that broke off and drifted southeastward and collided into the volcanic island arcs? So the answer is Palawan and Mindoro Island. So Palawan is not originally part of the Philippines. It's actually part of the mainland Eurasia. How would you compare the age of this island to the volcanic island arc? The Palawan block is older than the volcanic island arc in the Philippine Mobile Belt because it was relatively young. And now for the fourth picture, compression lifts ancient coral reefs and seafloor into high mountain ranges like which mountain ranges? So the answer is Sierra Madre and Cordillera Mountains. And then squeezing forces created which fault that relieves tectonic strain and frequently reshapes the terrain. So it resulted to the formation of a fault known as the Philippine Fault Zone. And then for the fifth picture, that is the present Philippines is a result of what type of convergence? So it is a result of oceanic convergence of the Philippine Sea Plate and the Sunda Block of Eurasia. So what are the evidences such as geological formations of this event? So the active volcanoes in the Philippines, the deep trenches and mountain ranges, and the fault systems. And now for our short discussion, the Philippine Formation. Many parts of the Philippines originated from oceanic convergence. One oceanic plate subducted over the other. So from our previous topics about plate boundaries, we learned that when two oceanic plates converge, it results to the formation of volcanic island arc. So Philippines, from this lesson, we learned that it is actually volcanic island arc. Philippine Mobile Belt is squeezed between Sundaland Blanc of Eurasia and Philippine Sea Plate. Majority of the islands in the Philippine Archipelago are considered as part of the Philippine Mobile Belt. These islands were formed 65 million years ago at the southern edge of the Philippine Sea Plate and are considered as part of island arcs. Other parts of the Philippines, such as Palawan, Mindoro, and Zamboanga Peninsula, are the highland sections of the Sundaland Block of the Eurasian Plate. And now for our generalization, the Philippine Archipelago is not a static landmass, but a dynamic, evolving product of millions of years of tectonic activity, formed through a combination of oceanic subduction, volcanic island arc eruptions, and continental drift. The islands continue to be actively shaped today by the very same forces that created them. And now get your notebooks and your pen. It's time for assessment. Number 1. Which island block in the Philippines originated as a micro-continental fragment that drifted from the mainland Asia rather than forming from underwater volcanic arcs? A. Mindanao, B. Panay, C. Luzon, or D. Palawan. Number 2. The main body of the Philippine Islands sits within a highly active tectonic zone caught between major converging plates. What is the structural geological unit called? A. Sundaland Block, B. Philippine Mobile Belt, C. Mariana Arc System, or D. Eurasian Margin. Number 3. How did subduction zones lead to the creation of early volcanic cores of Luzon, Visayas, and Mindanao? A. Dense oceanic crust dive into the mantle, melting rock into magma that erupted as underwater volcanoes. B. Continental plates slid horizontally past one another without generating magma. C. Glaciers carved deep mountain valleys that filled with volcanic ash. Or D. Diverging plates allowed lava to erupt at mid-ocean, spreading centers. Number 4. Which prominent tectonic feature extends approximately 1,200 kilometers through the length of the archipelago to accommodate tectonic stress? A. San Andreas Fault, B. Manila Trench, C. Philippine Fault Zone, or D. Philippine Trench. And last number, what type of convergence occurred that formed most of the Philippine Islands? A. Oceanic Continental, B. Continental, C. Oceanic, or D. Transform Fault. And now let's check your answers. Number 1, the correct answer is D. Palawan. It is part of the mainland Asia. Number 2, letter B. Philippine Mobile Belt. Volcanic island arcs squeezed between Sundaland Block and the Philippine Sea Plate. Number 3, A. Dense oceanic crust dived into the mantle, melting rock into magma that erupted as underwater volcanoes. Number 4, C. Philippine Fault Zone. Tectonic features extends approximately 1,200 kilometers. And last number 5, it's letter C. Oceanic convergence caused the formation of most of Philippine islands. How did you do, class? Did you get a perfect score? Congratulations! Now for ways forward, research one active volcano, for example, Mayon, Taal, or Pinatubo, or trench such as Manila Trench in the country. Write a 3-sentence summary on how it connects to active subduction zones. See you next lesson. Remember, forged in the fire of ocean depths, gathered through ancient collisions, and sculpted by the restless sea, the Philippines is living proof that beauty rises when Earth refuses to stand still. And now, welcome to our Day 2. Still, our topic is Philippine Archipelago. We still have the same competency. And then, for our objectives, at the end of the lesson, learners should be able to, first, identify and explain the geological evidences proving that plate convergence and subduction occurred and continue to occur in the Philippines. Number 2, map and classify real-world Philippine geological landforms. Number 3, evaluate the dual nature of convergent boundaries, how they create natural hazards while also providing beneficial resources. Think about it. Are you familiar about the Dicas volcano? Initially, it is an underwater volcano that erupted last 1773. It permanently broke the surface during violent eruptions in 1856 and grew significantly during a major eruption in 1952. The Dicas volcano serves as a living proof that the Philippines is a dynamic, ever-changing landmass, where active tectonic subduction continuously builds new islands and reshapes our geography in real time. Today, we'll investigate more evidences that will prove Philippines emerged from converging oceanic plates. Are you ready? For our learning experience, we will have an activity titled Footprints of Convergence. Our materials: volcano, earthquake, trench, and mountain ranges distribution map of the Philippines and the worksheets. For the direction, the students will observe the distribution maps and then they will answer the guide questions. So first picture is the distribution of volcanoes and trenches in the Philippines. So the red triangle indicates an active volcano. The yellow triangle indicates potentially active volcanoes. And then the green dots represents an inactive volcano. And then the purple lines with corrugation represents trenches. So from the image, we can observe the alignment of the volcanoes. And then we can also see the trenches such as the Philippine Trench, Cotabato Trench, and then there's also Manila Trench and Sulu Negros Trench. And then the volcanoes, and then the prominent volcanoes such as the Pinatubo, and then the Mayon volcano here in Bicol, and then we have the Iriga Mountain, the Mount Isarog, Mount Bulusan, Mount Canlaon. So these are the distribution of volcanoes and the trenches in the Philippines. And now for guide question number 1, look at the symbols for active volcanoes. Are they randomly scattered all over the country? Or do they form distinct lines or belts? Name one chain or belt of active volcanoes you observe. Number 2, look at the purple line features representing ocean trenches such as Manila, Philippine Trench, and Cotabato Trench. Where are these deep sea trenches located relative to the main island groups of Luzon, Visayas, and Mindanao? Number 3, compare the position of a trench to the nearest chain of volcanoes. What pattern do you notice between the trench and the volcanic arc? Number 4, why do volcanic arcs always form a short distance parallel to ocean trenches rather than a right inside the trench itself? And now for the second picture, the distribution of earthquake epicenters in the Philippines. The red dots represent the 0 to 69 kilometers or the shallow earthquakes. The green dots represent 70 to 299 kilometers depth of epicenter. And then the blue dots represent 300 to 700 kilometers. These are the deep epicenters. So usually the more destructive are the shallow ones. For the guide questions, where are the earthquake epicenters most condensedly clustered on the map? Second, look at the concentration of earthquake epicenters near the trenches. How does earthquake activity relate to the presence of ocean trenches? And last number, looking at the location of Palawan, why does it experience fewer earthquakes compared with other parts of the Philippines? And now for the distribution of mountain ranges in the Philippines. So this map shows the mountain ranges here in our country, such as the Sierra Madre, the Cordillera Central, the Zambales Mountains, and then we have the Bicol Cordillera, the Wata Mountains, the Pantaron Range, Kitanglad Mountains, and the Apo Range. Guide question: on a topographic map of the Philippines, locate the major mountain chains. Which direction do these mountain chains run? Example, north to south or east to west. Number 2, geologists have found ancient coral reefs, marine shell fossils, and oceanic limestone thousands of feet above sea level in the Cordillera and Sierra Madre Mountains. How does finding sea creature fossils at the top of a mountain range serve as evidence of tectonic uplift caused by converging plates? And number 3, the Sierra Madre runs along the eastern coast of Luzon, parallel to the Philippine Trench and the Philippine Fault Zone. How do the forces of plate subduction along the trench contribute to the continuous pushing up or uplift of the Sierra Madre? And now for the presentation, selected students will now present their output before the class. They will answer the guide questions. And for the expected answers, for the distribution of trenches and volcanoes. Number 1, look at the symbols for active volcanoes. Are they randomly scattered all over the country, or do they form distinct lines or belts? Name one chain or belt of volcanoes you observe. The active volcanoes are not randomly scattered. They are arranged in distinct lines or volcanic chains. They are arranged in distinct lines or volcanic belts. One example is the Luzon Volcanic Arc, which includes volcanoes such as Mayon, Taal, and Pinatubo. Number 2, look at the purple line, features representing ocean trenches. Where are these deep sea trenches located relative to the main island groups of Luzon, Visayas, and Mindanao? The ocean trenches are found off the coast of the main islands. The Manila Trench lies west of Luzon. The Philippine Trench lies east of Luzon, Samar, Leyte, and Mindanao. And the Cotabato Trench is located southwest of Mindanao. Number 3, compare the position of a trench to the nearest chain of volcanoes. What pattern do you notice between the trench and the volcanic arc? The volcanic arcs are located parallel to and a short distance inland from the ocean trenches. This shows that volcanoes tend to form in belts that run alongside nearby subduction trenches. Number 4, why do volcanic arcs always form a short distance parallel to ocean trenches rather than right inside the trench itself? Volcanic arcs form slightly inland from the trench because the subducting oceanic plate sinks beneath another plate. And now for the distribution of earthquakes. Where are the earthquake epicenters most densely clustered on the map? Earthquake epicenters are most densely clustered along the boundaries of tectonic plates, particularly near ocean trench like Philippine Trench and near Philippine Fault Zone. Number 2, look at the concentration of earthquake epicenters near the trenches. How does earthquake activity relate to the presence of ocean trenches? So earthquake activity is generally higher near ocean trenches because trenches are commonly associated with subduction zones, where one tectonic plates move beneath another. Number 3, looking at the location of Palawan, why does it experience fewer earthquakes compared with other parts of the Philippines? So Palawan experiences fewer earthquakes because it is relatively far from the major active subduction zones and trenches that surround much of the Philippines. And now for the answer key for the distribution map of mountain ranges. Number 1, on a topographic map of the Philippines, locate the major mountain chains. Which direction do these mountain chains run? Most of the major mountain chains in the Philippines generally run north to south or northwest to southeast, roughly parallel to the elongated shape of the archipelago. Examples include Cordillera Central in Luzon, Sierra Madre along eastern Luzon, and several mountain ranges in Mindanao. Geologists have found ancient coral reefs, marine shell fossils, and oceanic limestone thousands of feet above sea level in Cordillera and Sierra Madre mountains. How does finding sea creature fossils at the top of mountain range serve as evidence of tectonic uplift caused by converging plates? Coral reefs could only have formed in a marine environment, meaning the rocks containing them were once at or near sea level. Their presence thousands of feet above sea level indicates that these rocks were uplifted by tectonic forces. Number 3, the Sierra Madre runs along the eastern coast of Luzon, parallel to the Philippine Trench and Philippine Fault Zone. How do the forces of plate subduction along the trench contribute to the continuous pushing up or uplift of the Sierra Madre? Subduction along the Philippine Trench creates strong compressional forces that push and deform the crust, causing the Sierra Madre to gradually uplift and rise over time. Philippines is the result of long-term tectonic plate convergence. So as you can see from the picture, the Philippine Sea Plate subducted over the Eurasian Plate. Several plates and microplates have interacted, collided, and subducted around the Philippine archipelago. This ongoing movement has shaped the country's mountains, volcanoes, trenches, and earthquake zones. On the eastern side of the Philippines, trenches like Philippine Trench and East Luzon Trough are both products of subducting Philippine Sea Plate beneath the archipelago. Aside from formation of trenches and troughs, the downward movement of oceanic lithospheres underneath the Philippine archipelago creates active volcanic chains. For example, the descent of the West Philippine Sea oceanic lithosphere along the Manila Trench created a volcanic chain from Taiwan to Mindoro. Aside from the formation of trenches and troughs, the downward movement of oceanic lithosphere underneath the Philippine archipelago creates active volcanic chains. Also, the constant dipping movement of slabs induces frequent moderate to strong earthquakes at various depths, gives rise to mountain ranges, and develops the geologic character of Philippine archipelago. Palawan is originally part of the Sundaland block of Eurasia. It is older than the relatively newly formed volcanic island arc of Philippines. It is away from tectonic movements, so it experienced lesser earthquake. And for our generalization, convergence isn't just an abstract theory on a textbook map. It is carved into the very landscape of our country, from the deepest ocean trenches to our highest volcanic peaks and mountain ranges. The Philippines is a living laboratory of plate tectonic evidence. And now for our assessment. Number 1, when analyzing a geological map of the Philippines, what relationship between ocean trenches and active volcanic arcs indicates active plate subduction? A. Volcanic arcs run parallel to ocean trenches at consistent distance inland. B. Volcanic arcs are scattered randomly without relation to ocean trenches. Letter C. Volcanic arcs form circular clusters directly inside ocean trenches. Or letter D. Volcanic arcs intersect ocean trenches at direct right angles. Number 2, geologists map extensive layers of marine limestone and fossilized seashells atop the Cordillera Central Mountain Range. What type of tectonic evidence does this finding provide? A. Evidence of sea level drops caused by global glacial cycles. B. Evidence of intense crustal compression uplifting ancient seabeds. C. Evidence of lateral strike slip faulting along coastal margins. Or D. Evidence of subduction-driven magma rising through the crust. Number 3. Which feature provides strong evidence that subduction and plate convergence occur around the Philippines? A. Coastal beaches. B. Sand dunes. C. River valleys. Or D. Ocean trenches. Number 4. What does the concentration of earthquake epicenters near Philippine trenches indicate? A. Active tectonic movement. B. Rapid river erosion. C. Only volcanic weathering. Or D. Stable crust everywhere. Number 5. Which combination provides the strongest evidence that the Philippines has been shaped by plate convergence? A. Beaches, rivers, dunes, and waterfalls. B. Lakes, beaches, caves, and coral gardens. C. Trenches, volcanoes, earthquakes, and uplifted mountains. Or D. Clouds, rainfall, forest, and river. And now let's check your answers. Number 1, letter A. Volcanic arcs run parallel to ocean trenches at a consistent distance inland. Number 2, the correct answer is B. Evidence of intense crustal compression uplifting ancient seabeds. Number 3, it's letter D, ocean trenches. Number 4 is A, active tectonic movement. Number 5, letter C, trenches, volcanoes, earthquakes, and uplifted mountains. How did you do? Did you get a perfect score? Congratulations! If you get a low score, don't worry. You may just rewatch the video and then answer the questions again. For our ways forward, research about metallic mineral deposits, gold, copper, chromite in the Philippines, and write a brief paragraph explaining how tectonic convergence and magma activity created these valuable natural resources. See you next lesson! Remember, from the abyss of our ocean trenches to the heights of our highest mountain ranges, every peak, fault, and fiery cone across the Philippines is a footprint left by giant plates in continuous, restless convergence. And now for our day 3, still our topic is the formation of Philippine Archipelago. For our competency, it's still the same. And for our objective for this day, number 1, identify hazards brought by convergence of plates. Number 2, assess the hazards in the local area of the students using Fault Finder app. Number 3, suggest ways to mitigate the effects of earthquake to their local area. Think about it. What will happen if you bend a ruler and then you let go in one hand? So the ruler will quickly return to its original position. So just like the ruler, our plates also bend, but sometimes they return to their original position. So this causes earthquake. Now, let's look at this model. This is a model of convergence between continental and oceanic crust. So this is called elastic rebound theory. Convergent plates push against each other. Strain builds up until the rock ruptures, releasing massive energy. So today we will discover what are the hazards caused by earthquake and assess our local area of the risk brought by it. Unlocking of difficulties. Number 1. It is the visible vibration, movement, or swaying of the Earth's surface. Number 2. It is the movement of a mass of rock, debris, or soil down a slope due to earthquake. 3. It is a series of massive ocean waves caused by undersea earthquake or volcanic eruption. Number 4. It is a physical process where water saturated, loose soil temporarily loses its strength and acts like a thick liquid instead of a solid. The correct answer for number 1 is ground shaking. Number 2, landslide. Number 3 is tsunami. And number 4 is liquefaction. And for our learning experience, we will have an activity titled My Local Risk Profile. Materials, local risk profile form, fault finder app, application, cell phone, or laptop. So the task, the students will group themselves according to the barangay they live. And then they will use the fault finder app, then accomplish their local risk profile. So in using the fault finder app, we may use our phone or our laptop. First, enable location and data. Turn on your mobile data or Wi-Fi and activate GPS location tracking on your device. Second, launch the tool. Open the Philbox Fault Finder app or go to the official Philbox Fault Finder web portal. Number 3, find your current location. Tap Active Fault Nearest You or VFS Fault Nearest You if you are in Greater Metro Manila to automatically calculate the distance from your exact GPS coordinates to the nearest active fault trace. Step 4. Search by administrative area. Select the active fault based on location. Option to manually search and filter from the regional down to the barangay level to check specific properties or communities. Number 5. Explore manually via map. Double-check or tap directly on any target area of interest on the interactive map to query local fault traces and view mapping metadata like the fault name and mapping year. So this is our guide in using the Fault Finder app. So this is a sample of the result of Fault Finder and assessment of risk in our schools. And then the seismic hazard assessment. The nearest active fault is approximately 54 km north of the Legazpi lineament. And then for ground rupture, it is safe. Ground shaking, it is prone. Prone up to intensity 8. For landslide, it's unavailable. So it's actually safe because our school is away from mountain. And then for liquefaction, it is safe. For tsunami, we are also safe. Students that live on different barangays, even in the same city or province, may show different risks. After using the application, students should accomplish the local risk profile. So the hotlines are included for the MDRRM, PDRRM, and the health office. And then write the name, barangay, municipality, and province. Or if they live in the city, they may just put the city. And then the nearest fault line, what is the nearest fault line to your area? And then the distance of the nearest fault line. And then are you prone or are you safe from ground shaking, landslide, tsunami, and liquefaction? So knowing the hazard assessment of your barangay, make a 3 to 5 practical mitigation measures such as securing furniture, preparing emergency kits, identifying evacuation areas, conducting earthquake drills, strengthening vulnerable structures, and keeping the emergency routes clear. Each group will present their outputs to their classmates. Plate convergence. It occurs when tectonic plates move toward one another. This movement can produce intense geological activity, particularly along subduction zones and collision zone. The movement in interaction of converging plates can generate earthquakes and, in some settings, volcanic eruptions, tsunamis, landslide, and ground deformation. The Philippines is located in a tectonically active region, making knowledge of earthquake hazards and preparedness especially important. So assessing risk is important because it helps us identify possible hazards, determine who and what may be affected, and prepare ways to reduce their impacts. In earthquake-prone areas, risk assessment helps communities. Number 1, identify hazards such as earthquake, landslide, and tsunamis. Number 2, locate vulnerable areas such as schools, houses, roads, and bridges. Number 3, prepare appropriate safety measures before an earthquake happens. Number 4, reduce damage and injuries by planning ahead. And the number 5, make informed decisions about evacuation routes. And now, to always remind yourself to be prepared, fill out this commitment card. Because I live the distance, kilometer away from the active fault, I promise to. So what should you do? Because my safety is my responsibility. And now it's time for assessment number 1. Which hazard is most directly associated with sudden movement along a fault? A. Drought, B. Earthquake, C. Flood, caused by rainfall, or D. Heat wave. Number 2. Which hazard may occur when a large undersea earthquake suddenly displaces the seafloor? A. Tsunami, B. Drought, C. Tornado, or D. Heat wave. Number 3. Why is the Fault Finder app useful in this lesson? A. It predicts the exact time of an earthquake. B. It measures daily rainfall. C. It prevents earthquakes from occurring. Or D. It helps locate faults and assess possible earthquake hazards. Number 4. Which is an appropriate earthquake mitigation measure? A. Ignoring earthquake warnings. B. Blocking evacuation routes. C. Conducting regular earthquake drills. Or D. Staying near windows during shaking. Number 5. What is the main purpose of earthquake hazard assessment? A. To eliminate earthquakes. B. To identify risks and prepare appropriate mitigation measures. C. To stop plate movement. Or D. To predict the exact date of an earthquake. Number 1, the correct answer is B. Earthquake. Number 2 is A. Tsunami. Number 3, D. It helps locate faults and assess possible earthquake hazards. Number 4, conducting regular earthquake drills. And number 5 is B. To identify risk and prepare appropriate mitigation measures. How did you do? Did you get a perfect score? Congratulations! And now for ways forward, community earthquake preparedness. Learners will identify one earthquake-related risk in or around their home and propose 3 practical ways their family can reduce that risk. They may discuss their observations with a parent or guardian and report their proposed mitigation measures during the next class. See you next lesson! Understanding where earthquake hazards may occur helps communities prepare, reduce damage, and protect lives. And now we are on the final day of our topic, Philippine Archipelago, Day 4. Our competency is still the same, and for our objectives at the end of the lesson, learners should be able to: number 1, identify and explain the appropriate safety measures to take before, during, and after hazards such as earthquake, tsunami, and volcanic eruption. Number 2, demonstrate through role-playing the proper actions and safety procedures to follow before, during, and after an earthquake, tsunami, or volcanic eruption. Number 3, show preparedness, cooperation, discipline, and concern for the safety of others while participating in role-play activities involving different natural hazards. Breaking news. Magnitude 5.4 earthquake hits Mamburao, Mindoro Occidental, August 7, 2026. Another breaking news. T-Bolts braces for renewed eruptive activity in Mayon, August 18, 2026. Tsunami waves hit 6 areas after Mindanao earthquake, says T-Bolts, January 8, 2026. If ever these hazards occur in your area, do you know what to do? During times like this, we should stay alert and remember the do's and don'ts to ensure your safety. So for learning experience, we will have an activity titled, What Would You Do? Materials, infographics, and rubrics. So for the procedure, first, students will be divided into 3 groups. Each group will be assigned to a certain hazard and they will role-play the correct procedure to remain safe during this hazard. They will be given an infographic that contains what to do before, during, and after earthquake, volcanic eruption, and tsunami. They will plan first with their group mates and then they will be graded using a rubric. So this is the infographic about what to do before, during, and after an earthquake. And this is the infographic for volcanic eruption and what to do before, during, and after a tsunami. And this is the rubrics for each group. So performance rubric for natural hazard, role plays. So the criteria are accuracy, realism, and cooperation. So 10 points for exemplary, 7 points for developing, and 4 points for beginning. Overall, the perfect score is 30 points. So performance output, so each group will now present the role play that they planned. So for our generalization, these are the things that you should do before, during, and after earthquake, tsunami, and volcanic eruption. So you may post this video and then read the written table. And for our assessment, number 1, what should you do during an earthquake when you are indoors? A. Drop cover and hold on. B. Use the elevator to leave. C. Run immediately outside. Or D. Stand beside a window. Number 2. After receiving an official tsunami warning, what is the safest action? A. Go to the beach to watch the waves. B. Return home immediately. C. Wait near the shoreline for more information. Or D. Move to higher ground or a designated safe area. Number 3. Which is an important action to do before a volcanic eruption? A. Wait until ash is falling before preparing. B. Ignore official warnings. C. Prepare emergency supplies and know evacuation routes. Or D. Travel closer to the volcano. Number 4. What should you do after an earthquake? A. Follow instructions and check for possible hazards. B. Rush back inside immediately. C. Touch damaged electrical wires. Or D. Ignore possible aftershocks. And last number, which behavior shows cooperation and concern for others during a hazard? A. Causing panic among classmates. B. Ignoring evacuation instructions. C. Pushing others to get ahead. Or D. Helping others follow safety procedures when it is safe to do so. So the answer key, number 1, it's A. Drop cover and hold on. 2. D. Move to higher ground or designated safe area. 3. C. Prepare emergency supplies and know evacuation routes. 4. A. Follow instructions and check for possible hazards. Or D. And number 5, letter D. Helping others follow safety procedures when it is safe to do so. Ways forward. Application at home. Ask learners to discuss with their family. First, where are our safety places at home? Next, what should we prepare in case of an emergency? Where should we go if evacuation is necessary? See you next lesson. Preparedness is the key to safety. Knowing what to do before, during, and after a hazard can save lives and protect our community. Thank you for your support. Please like and subscribe to Sir Dom's blog. Goodbye!